This is a video tutorial for tutorial 5A question 14. Question 14 gives us the graphs of dy dx and d2y dx squared for the function y equals to f of x. We're also told that the function passes through the points 0, 0 and 2, 8. Knowing this, without finding the equation for y equals to f of x, we need to state the coordinates and of the maximum and minimum points of the graph y equals to f of x. Okay, so how do we do this? Well, we can see from the graph dy by dx equals to 0, and this is the first graph I'm referring to. This happens when x equals to 0 and when x equals to 2, just reading off the graph. So we can see that these 2 points, 0, 0 and 2, 8, are stationary points. So these guys are stationary points. So all we need to do is determine whether they are maxima or minima. How do we do that? Well, we do that by looking at the second derivative test, doing a second derivative test. So when x equals to 0, we can see that d2y dx squared is greater than 0. So that means that the point 0, 0 is a minimum. Oh, didn't know I could do that. Doesn't work twice. Yes, it does. Wow. Is a minimum. We also see that when x equals to 2, our second derivative has gone off the bottom, so it's negative, and that means that our point 2, 8 ought to be a maximum point. So that tells us that answers for the first part. What about the second part, where we need to sketch the graph? Again, we aren't allowed to find the equation, so we have to just go based on what we have. So again, this is going to be a little messy, I'm sorry, because I'm using a tablet rather than drawing by hand, but I think you guys should be able to get the general picture for this. So again, I'll try and do this as neatly as possible, but please do bear with me if it's not that neat. So set up our x and y axes. I know that the point 0, 0 is going to be a minimum. I also know that the point 2, 8, so 1, 2, 3, 4, 5, 6, 7, 8, let's put it up here. This point here, 2, 8, is going to be a maximum. Also, if I look at the graph, I notice that there's a turning point for dy by dx when x is equal to 1, and that tells me that likely I've got a stationary point of inflection when x equals to 1. So again, I don't know anything about it, but this point here, when x is 1, is likely to be a stationary point of inflection. Now, when x is less than 0, again looking at the first graph, I see that the derivative is negative, so this graph decreases towards 0 and has a turning point here, and then increases again, has a stationary point of inflection, but is still increasing. So we're still increasing until we get to x equals to 2. At x equals to 2, we start decreasing again. So this is something like the shape of y equals to f of x. So again, not very well drawn. I expect you guys to be able to draw a smoother curve, but this will give you a sense for what the shape of the graph looks like and what the 2 key points you need to label 0, 0, 2, 8 are. Also, if you notice it, try to label the point x equals to 1 as a stationary point of inflection. So that's it for question 14.